This video is going to discuss centripetal acceleration and centripetal force. The objective is that students will be able to recite the equations and parameters of centripetal force and acceleration. So hopefully you have your notes with you and something to write with, and we can get started. First, I want to review some stuff about circular motion from the previous unit. The further something is from the center, the higher its velocity tangentially or linearly. So tangential velocities are linear in motion. And the angular speed would be the same everywhere along that radius r. So the linear velocity, which is v, or the tangential velocity, is equal to the radius times the angular speed. So we talked about angular speed a lot in the previous unit, and we're not really going to discuss that too much here, but I just want to point out that I'm talking about this tangential or linear velocity, the one with the green arrow. Centripetal acceleration, since an object moving in a circular path is constantly changing direction, it's also accelerating. This acceleration depends on the tangential speed and the radius of the motion. The equation for centripetal acceleration is that tangential velocity squared divided by the radius that it's circling around. So that AC stands for centripetal acceleration, measured in the normal units for acceleration, which are meters per second squared. V stands for the tangential or linear, in other words, velocity, measured in meters per second. And R stands for the distance to the axis of rotation, which is usually the radius of the circle that's swept out by the moving object, measured in meters because it's the distance. Before I move on, I want to review Newton's second law of motion. According to that, the acceleration of any object is directly proportional to the force acting on it and inversely proportional to its mass. And the equation for that was force equals mass times acceleration, basic form of Newton's second law. So if that acceleration there were a centripetal acceleration, then if we multiply m times the stuff for centripetal acceleration, we can get a new equation for the centripetal force. So the centripetal force, CF, equals MAC, the centripetal acceleration. So if we plug in the equation for AC, the centripetal acceleration being v squared over r, then we end up with the equation for centripetal force being mv squared over r. Time for a challenge question. It says a mass is tied to the end of a string and flung in a circular path above someone's head. Got some typos here. If the tangential speed of the mass is doubled, by what factor will the centripetal force change? Will it be twice as much, 4 times as much, half as much, or 1/4? If you pick double times 2, that would be incorrect. Times 4 because the v is squared in the equation. So you got to square the factor. Doubled is times 2 squared is times 4.